The climate on Earth will be very different in the future. The Arctic will in all likelihood be ice-free during the summer. Extreme precipitation, heat waves and drought will occur more frequently and be more intense. Our basis of existence will change, and millions of people will probably experience food shortage. You can join us on a journey to the climate of the future. Click on the icons and choose between estimated changes in temperature, precipitation, Arctic sea ice and ocean acidification. How the future will look depends on social developments and measures to limit emissions of greenhouse gases. This animation allows you to choose between two emission scenarios: moderate to high emissions and substantial reduction of emissions. The latter scenario requires the implementation of extensive measures to reduce our emissions. Click on the buttons and see how the changes in temperature, precipitation, Arctic sea ice and ocean acidification are estimated for the two scenarios. The maps you will see are projections. They provide a picture of what the future climate may look like in the years 2050 and 2100. The projections are based on the Bergen climate model, which has been developed at the Bergen Center for Climate Research. A journey to the climate of the future. The year is 2050. Social development is taking its course, but without strong measures being implemented to cut greenhouse gas emissions. The average temperature on Earth has risen by about 2 degrees. The most intense warming is occurring over land areas and in the northern hemisphere. In Norway, we are experiencing longer growing seasons and larger crops. Hardanger is no longer known only for its beautiful fjords and apple cider, it now attracts tourists on vineyard holidays. But more unpredictable weather, with heavy precipitation and landslides, also gives rise to bad years in various parts of the country. Further south, drought causes more frequent crop failures and bad years. The media report of rising numbers of deaths related to heat waves, fires and drought. 2100. We are approaching a global warming of 3 degrees. Across many land areas, the temperature has risen by 4 to 5 degrees since the 1850s. Politicians worldwide have failed to implement comprehensive measures to cut emissions. Global food production, water supplies and the ecosystem are at risk. Low-lying islands and coastlines are submerged underwater. Several 100 million people are affected by the climate changes. Africa, the Middle East and South Asia are among the areas most vulnerable to climate changes. The year is 2050. Despite comprehensive measures to cut emissions of greenhouse gases, the global temperature is slowly approaching 2 degrees. There are high expectations that the measures will give visible results in the latter half of the century. 2100. The world's leaders blow their own trumpets. The target of a maximum of 2 degrees global warming, which more than 190 nations agreed to during the historic climate conference in Copenhagen in 2009, has been reached. Nonetheless, vast land areas in Africa, Asia and Australia are experiencing record-high temperatures of up to 3 degrees more than pre-industrial levels. But without the aggressive cuts in greenhouse gas emissions, the level of warming would have been significantly higher. The worst climate catastrophes with drought, starvation, flooding, high mortality rates and millions of climate change refugees are averted. But how much did the greenhouse gas emissions have to be cut in order to reach the 2-degree target? Study the figure. The green curve shows how many gigatons of CO2 we could be allowed to emit with a global temperature increase of 3.5 degrees. The blue curve denotes the emissions we could be allowed to emit in order to reach the 2-degree target. As the curve shows, CO2 emissions must level out from 2015 and then be considerably reduced to achieve a zero-emission society from 2050 to 2100. The year is 2050. Drought is the biggest climate challenge. Lower levels of rainfall are reported in the Mediterranean countries, the southwestern United States, Argentina, and large parts of Australia. The Middle East is hit particularly hard, with up to 40% less rain since pre-industrial times. The lack of irrigation possibilities threatens the production of food and supplies of water and energy. Crops in certain countries in Africa suffering from drought have been halved in the course of only a few decades. At northern latitudes, however, rain is predominant. Areas which already had high levels of precipitation have become even wetter. Precipitation has reached record levels throughout the elongated country of Norway. Western Norway in autumn and winter is the worst affected. A higher frequency of extreme precipitation levels increases the risk of floods, avalanches, and landslides. 2100. The headlines grow worse by the day. Pakistan is hit by the worst flooding in history. Forest fires sweep across the arid Australian grasslands, and drought and desertification spread across the countries in the Sahel region. Drought leads to malnourishment and impedes child development. There are more diseases and increased mortalities. A record number of floods are reported in eastern Norway after weeks of heavy downpour. Crops fail in areas where it is too dry or too wet. The year is 2050. Drought is a major challenge in several regions worldwide, despite drastic cuts in greenhouse gas emissions. Farmers in southern Africa experience a little more precipitation than they would have done if measures had not been implemented. 2100. Changes in precipitation patterns continue, though at a slower pace because the temperature has stabilized. The drought problems in the Mediterranean countries and large parts of Africa and Australia are significantly less severe than they would have been if the drastic measures to reduce emissions had not been implemented. A belt of land in Central Africa is blessed with more rain than was the case at the beginning of the century. Annual precipitation levels in the Northern Hemisphere have fallen significantly compared with the scenario for high emission levels. The year is 2050. During the past decades, the climate in the Arctic and northern regions has changed dramatically. With temperatures of 4 to 5 degrees above pre-industrial levels, both sea and land ice melting are on the increase. The Inuit elders reminisce about the old days, when it was still possible to live by traditional fishing and hunting. There had been a lot of talk about a record low ice sheet in 2007. The Inuits recall how the summer ice had been almost halved from one year to the next, which had taken them and the world by surprise. The climate researchers had called it the tipping point, and warned that the summer ice could disappear before the end of the century. Now the researchers' warning is about to become a reality. 2100. Blue sea in the Arctic region is no longer headline news. The rate of warming has accelerated. The implications for the ecosystem, polar wildlife and traditional ways of life are dramatic. Ice-free waters have attracted many players, and a growing number of international companies are seizing the opportunities this offers. The silence is gone, along with the infinite white horizon. The year is 2050. The climate changes taking place in the Arctic region are unstoppable. Despite drastic cuts in emissions of greenhouse gases, the temperature continues to rise at twice the rate of the global average. During the summer, the sea ice sheet is merely a shadow of its former size. Less sea ice also means that there are fewer bright surfaces to reflect sunlight. This accelerates the warming process in the north. 2100. The small summer ice sheet in the Arctic region has remained reasonably stable in the past few decades, but polar bears and other polar animal species move across thin ice during the summer season. As a result of the changes in the climate, governments, oil companies and shipping companies are showing an interest in waters that are practically ice-free. The year is 2050. The world's oceans are absorbing large quantities of man-made CO2 from the atmosphere, resulting in heavy ocean acidification. The pH value has fallen by 0.17 units since pre-industrial times. This is equivalent to an increase in the concentration of hydrogen ions of more than 50%, representing a drastic change in acidity. There are substantial geographical variations. The rate of acidification in the cold waters of the Arctic and northern regions is significantly faster than in waters further south. 2100. Politicians have failed to win support for substantial cuts in emissions. This is bad news for the oceans. Global pH units have fallen by 0.3 units since pre-industrial times. In Norwegian and Arctic waters, the pH value has fallen at an even faster rate, making the marine organisms in these regions particularly vulnerable. The situation is alarming for marine organisms dependent on calcium for building calcium shells. The sea butterfly, which represents an important part of the diet of many species of fish, seabirds, seals and whales, is struggling to survive in the acidified marine environment. Coral reefs are also threatened. For thousands of years, they have served as important spawning grounds for numerous species of fish. Researchers do not have a complete overview of the wider implications, but they fear that destruction of the marine life may threaten the global food supply. The year is 2050. The measures to reduce greenhouse gas emissions have slowed down the rate of ocean acidification considerably. The global pH level has fallen by 0.14 units since pre-industrial times. At northern latitudes, ocean acidification is considerably greater than further south, but the rate of acidification has halved compared to the scenario for high emissions. 2100. Thanks to the substantial climate measures that were implemented to limit global warming to 2 degrees, pH values in the oceans have also levelled off as early as around 2050. Slowly but surely, pH values have begun to rise towards the end of the century. This is good news for the sea butterfly and, not least, for the world's largest colony of cold water corals. These are found along the Norwegian coastline and are important spawning grounds for a number of different species of fish. Thank you for joining us on our brief journey to the climate of the future. The estimates of the future climate are based on climate models, which always give a simplified picture of reality. The climate changes may be greater or smaller than those depicted in the 2 scenarios used in this animation. This will depend on social developments, the scope of the greenhouse gas emissions, natural climatic variations, and how sensitive the climate system is to any changes that occur. Nonetheless, we can conclude that a maximum global warming of 2 degrees is possible to achieve, but it requires drastic measures to be implemented fast. Otherwise, we are probably heading for a global warming of 3 degrees, which could threaten the basis of existence for millions of the world's population. It is the action we take today that will determine the climate of the future.